Okay, welcome again, everyone. Thank you for coming. Tonight, we have the great privilege of hearing from Dr. Brian Jeffs. He has prepared diligently. I've been talking to him for many weeks now, and it has been a privilege to see how much our faculty that do this have put into preparing and sharing their insights for you for this. We're interested in doing more here in the department than just offering an electrical or computer or cyber degree. We want your experience at BYU to be different in the best way that promotes your faith and has you leaving BYU feeling like you got a spiritual benefit in addition to just learning all the stuff we want to teach you. And we hope this is part of that. But if you do have feedback on ways we could do this, this is part of a broader introspection we're doing as a department to try and help you do that better. I am privileged to introduce Dr. Jeffs. I have a brief bio here that doesn't even begin to span a career and a life, but he's an interesting guy. Dr. Jeffs was raised and lived most of his life in Orem, Utah, and he's also worked in Southern California, the Netherlands, and Australia. He has BS and MS degrees from BYU, and he has a PhD from the University of Southern California, all in electrical engineering, and he's been here at BYU since 1990 as a professor. His area that he lectures in is digital signal processing, signals and systems, detection and estimation theory. He's worked along the way, Hughes Aircraft Company, where he served as a sonar signal processing systems engineer in their anti-submarine warfare group. His research currently at BYU is in digital array signal processing for radio astronomy, where he co-directs the radio astronomy systems research group, which is developing instrumentation, signal processing algorithms, etc. He served a mission in South Africa, enjoys basketball, skiing, mountain biking, and scuba diving. He and his wife, Karen, who is here with us tonight, thank you, celebrated recently their 50th wedding anniversary. They have 5 children, all happily married, and 14 grandchildren. Let's give a welcome to Dr. Brian Jeffs.
Takes a minute to get hooked up here. Thank you for those kind words, Dr. Camacho. I really, really appreciate that. I want you to know this is an honor for me to be here, and I'm excited about the topic, to talk about the interplay between electrical engineering and our faith in our Heavenly Father. And I'm honored that you're here, that you took the time. I know there's an important basketball game going on right now, so I'm doubly honored that you're here. Now, I am recording it on my DVR, so if you want to follow me home tonight, we can watch it together. That'd be a lot of fun. So let's see. I better put these on, or I won't be able to see what I'm doing here. So Dr. Camacho mentioned our family a bit. Karen, would you stand up for a minute? My dear sweetheart, Karen, this is our family. We recently had a family reunion up at Aspen Grove with all of our kids. And I tell you, without Karen, none of what Dr. Camacho talked about in terms of things that I've been able to accomplish. None of that would have happened. And even if it would have, it wouldn't have mattered without her. So thank you so much, Karen, for your support through my career. So we're going to talk first a little bit about radio astronomy. Well, I'll eventually get to what that has to do with faith. But my great partner and colleague, Carl Warnick, and I have been working together for 27 years in the field of radio astronomy, instrument development, and algorithms. And it's been a lot of fun. And what's cool about it is I call it, it's big science. It takes great big giant instruments. This is a picture of the Narrabri synthesis imaging array in Australia. The idea is you can take great big, they look like satellite TV dishes, right? But these are 25 meters in diameter. And if you have an array of them together, you can correlate the signals between the antennas and produce beautiful images of deep space. Here's a couple of examples. On the right, we have a supernova remnant. This is located in the Cassiopeia constellation area. You see this area in the summer, but you cannot see this with an optical telescope. It's only visible in radio frequencies. There's no light emitted, just radio waves. And you can see that beautiful expanding shell of the hot gases and dust as the aftermath of a supernova. On the left, we have the almost superluminal gas jets. Now, what do I mean by superluminal? That would be faster than the speed of light. This is matter that's ejected from a supermassive black hole at the core of a galaxy that's located in the Cygnus constellation area, right in the middle of the Milky Way. Again, you cannot see this with an optical telescope. So with radio astronomy, you can see things that are important. They tell us about the nature of the universe. You can see them, things that you cannot see with an optical telescope. So this picture is an artist rendering of what's actually going on with that Cygnus A active galactic nucleus. They used to call these quasars. Now they know what's really happening is there is a supermassive black hole that's spinning, and there's a spinning accretion disk of material that's being sucked into the black hole. As that matter dives into the black hole, it gets superheated, and some of it, instead of going over the event horizon and being sucked into the black hole forever to be dark, some of it spins up on the axes, and you see the yellow beams going above and below the black hole. Those are the jets, the ejected matter that we can see with the radio telescope. Super interesting stuff. Here's a very large telescope, 65 meters. This is also in Australia. And we use these for things like detecting pulsars. A pulsar is a rotating neutron star that's spinning and has a magnetic field and sends out a beam of pulses of radio waves naturally. So the area that Dr. Warnick and I have pursued for all these years includes kind of pioneering the area of phased array feeds for these great big giant single dish radio telescopes. Here's one of our former PhD students up inside of a 20-meter telescope dish at the Green Bank Radio Observatory in West Virginia. That's an early prototype and radio feed, has 19 antenna elements. That was an early start. The idea of a phased array feed is that you can, let's see if I can point here. I don't know if this, oh, you can see my mouse, good. The idea of a phased array feed is that instead of a dish looking in one direction at some object, we can digitally form using parallel processing computers multiple beams and get many pixels on the sky all at once instead of just one. That allows us to do surveys much, much more rapidly. So here's an example of an image that we produced with those early phased array feeds on the Green Bank telescope. That's a 100-meter diameter dish. That's bigger than a football field. And this little circle in the corner is what you would see with their existing current equipment. It's a single L-band horn feed, an antenna that's located up here at the focal point. And you only get to look at one point on the sky, one pixel. But using our prototype phased array feed, we're able to get this image of hydroxyl ions, OH ions in the Cygnus X region of the sky. Much more to see than meets the normal eye. So from there, we moved on. We had a great project the NSF funded to develop a phased array feed, a big, much larger permanent phased array feed for the Arecibo telescope. This is the Arecibo radio dish. It's 305 meters across. Our phased array feed was planned to go inside this 90-foot diameter dome. And again, the idea was to make this be a much more effective survey instrument. You could scan the skies and look for interesting objects much more rapidly than otherwise. Karen and I made a couple of trips to Arecibo, climbing around that structure. If you've ever watched the old James Bond movie, GoldenEye, the bad guy and James Bond fought on these very catwalks, and the bad guy fell down into the dish. So if you ever want to, it would be worth watching. Not that I'm endorsing James Bond. So, you know, that was the project, but just a little more than a year after these pictures were taken, well, we'll get to that. Okay, so we did develop and recently completed this large phased array feed. This whole front end is cryogenically cooled to close to absolute zero in temperature, so that it's very low noise and we can detect very weak signals. These are some of the students and professionals that have worked on the project for us. Rebecca Haymore is a graduate student. Mitch Burnett was a graduate student here. He's now a consulting engineer. End of them right now are at an observatory installing this front-end instrument. Here's the back-end digital beamformer with Mitch. And that's a look at what that antenna array looks like. 139 antenna elements. You combine them digitally to form multiple beams. Now, with that background, for your career, you have to be able to answer this question, or at least deal with it. Why do bad things happen to good projects? So I've got a little video to show you. Right in the middle of our project, the support structure cables broke, and the Arecibo Observatory totally collapsed. It has now been raised. They have removed all of the debris, all of the towers, and returned that site to its natural state. Here's another view from a drone. They were kind of watching damage to the cables with this drone. So much for building a phased array feed for the Arecibo telescope. So how do you deal with unplanned setbacks? Well, we were fortunate. We were able to make arrangements to relocate the Alpaca phased array feed to the Green Bank telescope, that big 100-meter dish that I showed you earlier. But unfortunately, after about 4 years of working with them, the policies of the US government changed in terms of research funding, and Green Bank needed to pull back from their research projects, and they withdrew from the Alpaca project. So yet again, another disappointment. So we searched high and low to try and find another large single dish telescope that could be an appropriate host for the Alpaca instrument. We have the greatest phased array feed in the world, and we just want a home for it. But yet again, another setback. It's so big because it's all cryogenically cooled and so heavy that there's not another telescope besides Green Bank and Arecibo that could have hosted it. So after 8 years of working on it and $7 million, we felt blessed that another opportunity, another option came forward, and that's to repurpose the Alpaca feed for use at the SETI Institute. Now, we'll talk more about that in a minute. Now, I've shown you just a couple of images that are produced by radio astronomy observatories and telescope systems. The things that they're finding, the understanding that is developing about the nature of the universe, not only our galaxy, but the universe, are just astounding. Every time Dr. Warnick and I go for a visit and sit down at an observatory with astronomers, we try and milk them for information. Okay, what's the current view of what the Big Bang was, and what are black holes, and what is the universe expanding or shrinking? And it's been a delight to rub shoulders with these great minds. But what we learned there really begs important and big questions for those of us who are people of faith. We believe in the gospel of Jesus Christ. We believe in the scriptures, and we believe in revelation from prophets and apostles. So for me, these are some big questions that this window to the universe opens up. How big is God's plan? Not just for us, but for his creation. What's out there? What's really out there? Is it all his, our Heavenly Father's? And more importantly, where do I fit in? Where do I fit into his grand plan? Have you ever sat out on a warm summer night in a dark mountain area and looked at the sky and just been in awe? Have you ever looked through binoculars or a telescope at the Milky Way and just gone, wow? I have. And the more I learn from the images that are produced with telescopes and radio astronomy, the more I am just floored, just overwhelmed with awe. So these questions arise. Well, let's talk about what we know about God's creation, about the grandeur of God's creation. So the Milky Way is our local neighborhood. You're all kind of science-oriented. You know what a galaxy is. So the Milky Way, Our solar system sits on just one arm of a whirlpool galaxy. We're kind of in the outer third, nearer to the edge of the galaxy. Milky Way contains between 100 and 400 billion distinct stars. The distance from one edge of the Milky Way to another is more than 100,000 light years. Light years, of course, the distance light travels within a year. That is massive. So what about our local neighborhood? If this is our neighborhood, what about our local neighbors? Well, the Andromeda Galaxy is the closest full-size galaxy. There are some smaller mini galaxies like this one right here, but the Andromeda Galaxy is 2.5 million light years away. If we were to try to travel there at the fastest we know anything can travel, the speed of light, now we can't travel that fast, but if we could, 2.5 million years to get there. It, like the Milky Way, is a spiral galaxy. It has 3 to 10 times as many stars as the Milky Way. It's huge. And we're actually orbiting each other, and they think, if they simulate it and run it forward in time, that eventually the two galaxies are going to mesh. Now, they don't exactly hit each other. There's a lot of empty space, but they'll kind of intermingle with each other. And if you want to try this on a summer night, if you look in the constellation Pegasus, there's a fuzzy star near one of the lower legs. That's actually the Andromeda Galaxy. That's the only galaxy other than the Milky Way you can see without a telescope. Okay. You know something about Hubble telescope images, and there are even newer instruments that are even more sensitive and have higher resolution. But what I'm going to talk about here are things that we learned for the first time with the Hubble telescope. This is the Hubble Deep Field Image, and take a look at that. What do you think you're seeing? Do you see any stars? Maybe one or two, but they intentionally chose a location in the sky. It's just in the Big Dipper, Ursa Major, just above the handle here, that had almost no stars of the Milky Way. It's a black spot that really nothing else was known about what was there. Okay, this is 1995. They pointed the Hubble telescope at that spot for 10 days. That's like a long exposure photograph, only the exposure is 10 days long. And with that long exposure, you were able to see things you otherwise couldn't. In that image, there are 3,000 galaxies. Each of those is between 100 and 200 billion stars. The most distant object, let's go back. Now these little spots here, the little spots, those aren't stars. Those are galaxies that are so far away, they're barely perceivable. They're 12.7 billion light years away, those smallest galaxies. Okay, so that's interesting because that means that the light we're seeing from those distant galaxies have been traveling for 12.7 billion light years out of the 13.7 billion light years since the Big Bang. So we're looking at the early stages, early beginnings of the universe. Okay, well, let's do one better. This was in 2012 with the Hubble telescope. They did the ultra deep field image, And you can see it looks similar. It's sharper, but there are even more galaxies. In this image, 5,500 galaxies. That was a 25-day long exposure. That's why they call it a deep field image. It was a blank area in the constellation Fornax. Now, to get an idea of how big that field is, can you see this little box here? That's the size of the area that is in the deep field image compared to the moon. So it's just a little bitty box. And with that, this is what you get. Now let's zoom in on that small area, and you can see some of the beautiful structure of those very distant galaxies. Now, in this image, let's go back. The most distant objects are 13.2 billion light years away. So what you're seeing is within 500 million years of the Big Bang. Wow, that's old light. It's been on its route for a long time. So now let's think about what we know through the restored gospel of Jesus Christ. We have access to prophets that the rest of the world is not aware of. But there are hints. There are hints in the Bible. So Hebrews 1:12. 1, verse 1 and 2. God hath in these last days spoken unto us by his Son, whom he hath appointed heir of all things, by whom also he made the worlds. Now notice that's plural, worlds. Do you think the rest of the, other than Paul, who probably is the author of this, of Hebrews, who else besides a prophet of God would have used the word worlds? They didn't know what stars were. They didn't know if there were other planets around. Okay, now, restoration scripture. This is Joseph Smith's revealed. He was revealed the scripture, the complete scripture that Moses wrote, a much more complete account than we find in the book of Genesis. And he beheld many lands, and speaking of Moses in his vision, this is Moses's vision, and he beheld many lands, and each land was called earth. And there were inhabitants on the face thereof. And by the word of my power have I created them, which is mine only begotten Son, who is full of grace and truth. And worlds without number have I created. Now go back to the deep field images. 5,500 galaxies in that one little spot, each of them with 100 to 200 billion stars, each with the possibility of planets around it. Does that sound like worlds without number? Science could not have said that before 1995. But prophet knew. Moses 7:30. And were it possible that man could number the particles of the earth, yea, millions of earths like this, it would not be a beginning to the number of thy creations, and thy curtains are stretched out still. And then finally, Moses 1:8 and 10. Now this is talking about Moses after this vision had closed. He had seen this grand vision of all of God's creation. The vision closed. And Moses beheld the world and the ends thereof, and all the children of men which are and which were created. Of the same he greatly marveled and wondered. He said unto himself, now for this cause I know that man is nothing, which thing I never had supposed. Do you think he felt humbled as he saw God's creations? I mean, it brought him to his knees. And that's kind of the awe that I have felt in my career as I see not only astronomy images and the knowledge that we gather there, but all of God's creations and the beauty and the grandeur of them. Okay, so that's very, very humbling. It makes us feel small in comparison. So it begs the question, where do we fit in? Do we count in that kind of a creation, that huge? What's my role? Do I matter? Well, in the Old Testament, in Psalms, when I consider the heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him? The psalmist asked that question. We're so puny. Why do you even bother with us? And the Son of Man that thou visiteth him? Back to Moses 1. This is at the end of the vision. The Spirit had departed. Moses was left on his own. Satan came, tempting him, saying, Moses, Son of Man, worship me. And Moses looked upon Satan and said, Who art thou? Who art thou? I am a son of God, in the similitude of his only begotten. And where is thy glory that I should worship thee? Though Moses first said he didn't realize that man was nothing, he later, through the Spirit, realized, well, wait a minute. I am something. I'm not going to follow you, Satan, because I am a son of God. Doctrine and Covenants 76. This is the great vision that Joseph Smith and Sidney Rigdon jointly saw together in the newly completed temple at, Ohio, Kirtland, at Kirtland. For we saw him even on the right hand of God, and we heard the voice bearing record that he is the only begotten of the Father, that by him and through him and of him the worlds, plural, are and were created, and the inhabitants thereof are begotten sons and daughters unto God. Well, that's how we fit in, and that's what Moses understood too. And this is in Doctrine and Covenants 84. And the same theme is actually taught in Romans chapter 8. And he that receiveth me receiveth my Father, and he that receiveth my Father receiveth my Father's kingdom. Therefore, all that my Father hath shall be given unto him. Paul uses the phraseology that we become, through obedience to the gospel, joint heirs with Christ. So it's the same concept. So this is big. When you see the greatness and grandeur of God, his powers and his creation, it's humbling. But then we realize that we matter because we are his children. And we can become joint heirs if we follow him. And these are mysteries that much of the world doesn't understand. We're blessed with the restoration. Okay, with that background, let's come back to the SETI Institute. I mentioned that the alpaca instrument has just been delivered there. In fact, I just talked to Mitch Burnett and Rebecca Haymore today, and they've completed reassembling the digital beamformer back end there. So this is their telescope array. It's used principally to search for technosignatures. So what is the SETI Institute? The Search for Extraterrestrial Intelligence. They have a slogan. Are we alone? Let's find out. Leading the search for life beyond Earth. That's kind of fun. So what they do is strategic sky surveys looking for technosignatures. Now, what does that mean? There are a lot of naturally generated signals in space. I mentioned pulsars and quasars and active galactic nuclei. Any matter that's not at absolute zero is actually emitting radio waves. And so you see it typically as noise-like or pulse noise-like signals. Something that's coming from an advanced civilization on another planet, another star, would have characteristics that don't look that random. It would look more structured. It would have telltale signs that it's really not naturally generated. So they have a big campus of research buildings in Silicon Valley, and they have this observatory at Hat Creek in northeastern California. But they also have really beautiful receiver back ends that they hook into radio telescopes around the world. They have a big installation at the Green Bank Telescope, and they did have one at Arecibo, and they've instrumented a number of the major telescopes around the world. They have 120 affiliated scientists. So I'm trying to point out that they're kind of legitimate, right? The search for extraterrestrial intelligence got poo-pooed for a while, but these are serious scientists, and they want to be thorough in a search to see if there is any evidence that we can find of other intelligent civilizations. They have a lot of money. They currently have an endowment over $100 million privately funded. So let me share with you an interesting conversation I had with a friend of mine, Jerry Harp. He used to be the director of SETI Institute and retired not too long ago. He happens to be a devout Christian, a practicing Catholic, a believer. We spent a lot of time together at conferences. We just kind of crossed paths, and wherever we were at an astronomy instrumentation conference, we'd go out to lunch together. And so anyway, I've had some good conversations. He asked me, knowing that we were working on these phased array feeds that would improve search rates, he had me present a seminar at the SETI Institute, and it was broadcast internationally. I had a lot of folks watching it, so he's just been really fun to work with. So while walking back from lunch one time at one of these conferences, I shared with him those scriptures that I just shared with you. And he'd never heard these before, other than the ones in the Bible. And he asked me, when was that written? And I said, well, it was translated or received by revelation in the 1830s by Joseph Smith. And he paused for a long time and kind of thought about that. And then he said, that was very forward thinking of Joseph Smith. And I didn't say it, but I thought, well, that's what a prophet is. That's what a prophet does. Forward thinking, forward seeing. And we exchanged emails, kind of discussing that topic back and forth for several months, and we remained good friends. He never asked to investigate the church, but he was absolutely impressed that, well, why would he be impressed? Let's think about what was known in 1830. 1832, they had been able to observe galaxies with the telescopes of the day, but they didn't know what they were. They just looked like they called them nebulosities. They didn't know they were galaxies like the Milky Way. They didn't know they were constructed of stars. So that was not in the knowledge of the day. They also didn't know anything about what we call now exoplanets. In fact, did you know that it's only been in your lifetime that it's actually been confirmed that there are planets around other stars? 1995 was the first time that they were able, astronomers were able to detect a, a, an orbiting planet around a main series stars. Now, what's a main series star? It's one like our star, one that could possibly support life. Okay, so. But since 1995, this is actually last month, end of February, there were 6,128 confirmed exoplanets and 4,560 planetary systems. So in some systems, they detected multiple planets. So here's one of them. This is the Kepler-37 system. Now, what we've got here is 3 known planets from Kepler-37, okay, mixed in with our solar system objects. So they found a planet about the size of the moon. They found a planet between the size of Mars and Earth, and one that's a bit bigger than Earth, but much smaller than Jupiter or Saturn. So what matters is, can we find planets that could possibly support life? Now, they talk about the Goldilocks zone. So for any given star with a certain amount of radiation energy, there's a zone where a planet would need to orbit in order to have water, possibly have water, have an atmosphere, not be a frozen ice planet or a Mercury-like planet that is just all melted metal. So you need a planet that's probably in this range of sizes, and you need to be in the Goldilocks zone. And they've actually found a handful that they've confirmed are candidates for possible life. So the point is that Moses was right, Joseph Smith was right, the prophets are right, Paul was right, things that science is just now catching up on, that there could be life on other planets. So this is just 3 weeks ago. We rented a big crane and lifted the receiver antenna cryogenic front end off of the roof of the Clyde building. And this is 3 weeks ago when we delivered it there to the SETI Institute Hat Creek Observatory. It will be a permanent instrument there. It's going to be fixed on the ground looking up. Instead of working with a dish, it's going to be a full sky monitor, and it's going to look for transients and technosignatures, and it'll allow them to cover a larger area of the sky with a sensitive instrument that can form many beams, kind of like a fly's eye, looking many directions at once. So its mission will be to find evidence of ET. Did you ever think of ET as being a fellow child of God? So it's in our doctrine. ET is there. It's in the scriptures. And they're our relatives. And there we're actually delivering the front end. Here's the rest of the system. And this is a shot that we took the day we delivered. I thought it was a good omen. Beautiful sunset there at Hat Creek Observatory as we delivered Alpaca. So it's another opportunity. Will we find techno-signatures? I don't know. But it's fun to be part of the search. And it's certainly consistent with the teachings of the restored gospel of Jesus Christ. So my take-home messages are God's handiwork is unimaginably, just unbelievably send you to your knees, grand beyond expectation. That's the first thing. God is great. The second is you and I are children of God, and we can even be joint heirs. And he did it for us. He created this world and others for his children. His mission statement is in Moses 139. For behold, this is my work and my glory, to bring to pass the immortality and eternal life of man. Through the atonement of Jesus Christ, the path is laid that we can become joint heirs with Christ and participate in God's grand work. I was about to say, I can't wait to be part of that. I can wait until it's time to die. I don't need to, I'm not dead yet. So, but I bear my testimony that God's love for us is shown in everything around us. It's been wonderful in my career to work with engineering principles, science, and math, and rub shoulders with scientists. And at every step, never have I encountered anything that would shake my testimony of the restored gospel of Jesus Christ. Everything I see speaks of the hand of God and of his love for us. And I say that in the name of Jesus Christ. Amen.
Okay, here. Let me start here.
That's it. Oh yeah, questions.
Okay. It's a great time. We thank you, Dr. Jeffs. Part of this experience, we want you, while you're in the moment, to think of some questions to ask Dr. Jeff. It could be anything that's on your mind related to his presentation, related to Dr. Jeffs and his career. What was he doing in, working on a submarine, whatever it is. It's a ask me anything session, and we'll take a few minutes and do that. If you remember to repeat the question so it's captured on audio, that'd be good. Okay.
Yes.
I heard that you discovered solid evidence of microbe life on Mars, like some kind of protein or amino acid or something.
Oh my goodness, that's news to me. So the comment or question was that there's recent news that they have discovered some solid evidence of at least building blocks of life on Mars. I'm unaware of that. That's tremendous, and that's exciting. Cool. Yes, question. Yeah. Oh my goodness, that's an important question, and I'm certainly not the only source of advice to go to for that. But as I said, it's been an honor. It has truly been an honor to teach incredibly capable and faithful young men and women as a teacher here at BYU. And I think I would echo, I believe this was, help me out. Who said this? Might have been President Oaks some years ago. If you have doubts, doubt your doubts. Yeah. Who was it? To President Uchtdorf. Yeah. I mean, because a lot of things happen in your life that challenge you, and you're among different groups of people with different beliefs, and their different pressures and stresses. Hold fast to that iron rod and Be patient, doubt your doubts, because the wonderful thing is that that invitation to read the Book of Mormon and to ask if it is true, and that the truth of it will be revealed unto you, that is not a one-time offer. That is for every time that you doubt or wonder or need a little boot up or even just want to get farther down the road. Always be patient with your doubts, doubt them, and keep pursuing confirmation. So that would be my advice. Yes.
What experience you had with revelation in your research and in your career? And what advice would you have to us as we seek to do hard things and try to learn things that are not knowable? What's your advice for involving the Lord in that? And if you have any,
Wow, good question. So the question is, I'm repeating it so it'll get on the recording. What advice do I have, or have I had, what experience have I had with revelation in my life and career? And the second part was
how you can help us to receive that same help from God.
okay, advice to receive the same help. I definitely have felt inspiration many times. First of all, you got to ask. You've got to pray. You've got to ask. I remember there was a time in my career where I was struggling. I was worried about qualifying for continuing faculty status. You may have heard it called tenure. So faculty members have a period of kind of probation for a few years, and you come up for evaluation to see if you can get tenure status. And I was struggling to have I needed a new research topic. I was kind of at a dead end, and that date for evaluation for tenure was looming. And struggled and prayed and worked and just asking for guidance. And just one day I went to the temple just on my own, just to ponder and think about things. And I didn't specifically ask for a revelation in the temple about a research topic, because I thought that's not really appropriate. And while sitting in the endowment room, an idea I had never had popped into my head of a new approach for digital image processing, particularly for astronomical images, came to me. And it was a great idea. It led to several publications. And I am convinced that was a direct answer to prayer. It took some patience and time. It didn't come immediately. So the advice I would give is, number one, ask. Strive to be faithful so you can be a receiver of prompting and inspiration. And be patient. It'll come. Pray when you are preparing for an exam. It helps. Thank you. Question?
There's no home for those. Was there ever a moment when you accepted the fact that it might never go anywhere?
I worried about it, but I never accepted it. Dr. Warnick can share his feelings on that too. I mean, it was our biggest project at the time, and so much work and time. I've never shared this with anyone, let alone our fellow project collaborators. We were working with Cornell University and University of Arizona, but I did have a very, very strong prompting at that time to go talk to SETI Institute. And what was funny about that, this is before we went to Green Bank. And it was just clear to me that's where it needs to go. But that was not what our collaborators wanted to do. That's not what it was designed for. That's not what we were shooting for. And the most obvious solution was to go to Green Bank and put it on another very large radio dish and have the same research goals. And but that sat in my mind for the 4 years since, until, guess what? Green Bank withdrew and said he was interested. And I think it was an inspiration to prepare me to be willing when the time came to say, okay, let's go do that. There's a reason to do that. Yeah. Yes, Sam.
But how real are those colors? Are those actually real?
Well, the problem with that question is color isn't real. So it's all perception, right? And it just so happens that humans have a red, green, blue vector processor to look at the light spectrum and interpret it as red, green, blue. So, but so a lot of those are pseudo color, which means that what we're doing is taking different radio frequencies and mapping them to different colors. Okay. So it gives some contrast, so you can recognize, well, with that color, that's probably neutral hydrogen that's emitting 1420 megahertz. And this color might be a different radio temperature, something like that. But it's a good question. Yes. Well, I'm planning to retire in July, so it's coming up soon. It's going to be hard to go. It's going to be hard to leave this. This is a great institution. It's been a joy of my life to be here. Question? Could you repeat that? That's a good question. So we operate with a compressor, just like room air conditioning. There's a great big compressor that compresses gas and lets it expand, and it cools. But you can't use Freon or anything like you would use in air conditioning. You have to use helium. So the gas that you cool with is helium, and then you have a 2-stage cold head. That anyway, it has to be continually chilled, and it has to be in a vacuum. That whole instrument is a vacuum chamber, because you can't fight all of the heat trying to get in unless you have a vacuum. It's like a thermos bottle. So yeah, it has to be actively cooled. It only uses about 5 kilowatts to cool that continually. Okay. Yes. The favorite project I've worked on or ever seen or overseen. My favorite. I love them all. It's like asking which is my favorite kid. But they've all been fun. Some have been more productive than others, but the largest project was this alpaca project. That was the largest grant we ever had, and had all kinds of fun, challenging problems to work with. It's been the biggest headache too, because we got shut down 3 times. So, yeah. I think.
Got you out of like straight like DSP and into like how'd you get out of like pure DSP into like
When I saw the light, and I no. So the question was, what took me from straight DSP to radio astronomy DSP, something like that. Well, I mean, my DSP career started doing sonar signal processing. And I come to BYU, there's no sonar collaborators here. And so, you know, what you do as a professor sometimes is you follow the money. You find where you can get funding for something you enjoy doing. And so, you know, I know how to do digital beamforming and detection theory. And guess what? We do that in radio astronomy. So you'll find in graduate school, when you get there, if you're not there already, in a way, it's all the same stuff. You know, the same techniques and theory can be applied to many different applications. There's a lot of fruitful opportunities there.
Just take one or two
Okay.
questions.
Well, I got two hands. We'll make them quick. So along my career, pardon me? Oh, my biggest mentor. Well, my first biggest mentor was my professor when I first took digital signal processing here, Douglas Shabrias. He was dean of the college for a while. In fact, I was in computer engineering and had been, it was I loved computer engineering, but I took that class and I said, I got to do this. And he really kind of led the way. And then my current greatest mentor is Dr. Warnick. The two of us make a good team. So thanks. And then one more question.
How do we actually estimate that distance?
Oh, that's a very good question that we don't have time to answer. But there's several methods. For nearby objects like stars, you can actually use parallax, and that's very accurate. And what you do, you know, if I'm looking at you compared to the guy sitting in front of you, that's different. If I go over here, now your position is moved relative to a nearer object. And so you let the Earth go halfway through its orbit around the annual orbit of the sun, you get some parallax shift for nearby stars. Then you kind of leapfrog beyond that. The next thing, you've heard of the Hubble constant. Okay. This was discovered in the 50s. Is that right? In the 50s? That the Earth or everything in space is expanding kind of uniformly away from each other. And the farther things are away, the faster they're receding from us. So you get what's called a Doppler shift, a red shift. So you can actually correlate the Doppler shift. How you know that hydrogen has a certain natural radiation frequency, both visible light and radio. And if it's moving away, you can identify that structure, that pattern, identify the atomic matter, but it's shifted in frequency. From that frequency shift, you can infer how far away it is. So that's it. Thank you so much, everyone. Thanks, Steve.
Please help us clean up by taking food and eating it, either here or somewhere else. And thank you again for coming. We'll see you at the next one.